So in the last lesson, we looked at the budget constraint. We introduced the topic of the budget constraint, and we said that everybody has a finite amount of money to spend. Well, whenever we're going to expand on the budget constraint, we're going to start off by talking about total expenditures. So total expenditures is the total amount that a consumer or a household will spend on all of the goods that they're going to buy. And if you remember, with that budget constraint, you have a finite amount of income, and you cannot spend over that amount of income. So your total expenditures cannot exceed that budget constraint, cannot exceed that total or that amount of income. The total expenditures either needs to be at or below that income. Otherwise, you're spending more than you're making, and that just really doesn't work, especially not in the long run. So total expenditures is the total amount of goods and services bought by a consumer. And we can calculate that, and we can figure that out by taking the number of each good or service and multiplying it by its respective price and totaling the values of all the purchases. Simple enough, right? You take the goods that you bought times the prices that you bought them at, and then add all that up. I mean, it's relatively simple. And all we're doing is, when these total expenditures, is we're simply calculating the total amount of money we spent. Imagine this. You go into a place like Walmart, and you pick up 2 folders, a couple packages of pencils, and then you go and you buy a bag of fruit. Well, how much money did you spend? Well, and at the checkout, it's ringing it all up, and it's saying, well, we bought 2 packages of pencils at $1 a piece, so that's $2 we spent on pencils. We got 2 folders at $0.25 a piece, that's 50 cents spent on folders, so we're up to $2.50. And then we bought this package of oranges for another $2.50. So we spent a grand total of $5, and that would be our total expenditures right then and there at Walmart. So this total expenditures is basically a formalized way of saying how much money did you spend. So let's compare it back to the taco and burger example. We're going to use a taco and burger example whenever we're talking about the budget constraint. So let's say you have an away from home budget. You say that I can spend only a certain amount of money away from home, and whenever you do that, you decide that you're going to eat either tacos or burgers away from home, or both. You decide that whenever you're going to eat away from home, you're going to pay money to have somebody else cook food for you. It's either going to be tacos or burgers, and that's going to be spent on away from home. That's going to be your away from home food, and you have a specific budget tied to that away from home food. So how much money do you spend? What is the amount that you spend on away from home food? Well, if you only buy tacos or burgers away from home, that budget, that equation becomes relatively simple. The amount of money, the amount of income that you spend on away from home food would then be equal to the number of tacos times the price of the tacos, or plus the number of burgers times the price of the burgers. So the budget limits the consumption of tacos and burgers to the total income allocated to their consumption. And basically what that means is you have a budget on away from home food. Just like up here, we said you had away from home food budget. So the amount of tacos and burgers that you consume, therefore, is limited by the total amount of income that you allocate towards that consumption, that you allocate towards the consumption of either tacos and or burgers. So we're going to kind of reiterate something. This means that the budget constraint is therefore limited to the price of the item and the income. That's something we talked about in the last video, because here we're talking about it that if your income changes, if your budget right here changes, then of course you can probably buy more tacos or more burgers or both. Or if the price of tacos changes or the price of burgers change, then you might be able to buy more tacos or burgers because now they cost more or less, meaning that you can allocate the different amounts of that budget. So let's kind of go through an example. And let's say that you have $5 to spend on either tacos or burgers. We said that away from home budget is actually equal to $5. And again, you only eat tacos or burgers away from home. And we figure out that tacos cost 50 cents and burgers cost $1.25. So how are you going to allocate that $5 to maximize your satisfaction? Because remember, the whole consumer theory is trying to maximize your satisfaction given a finite amount of money, given a limited budget. So here's our limited budget. We have $5 to spend. 50 cents on tacos or $1.25 on hamburgers. So what if we buy only tacos? If we buy only tacos, well, we could buy 10 tacos and no burgers, and we spend exactly $5. See, we know that because it's 10 times 50 cents plus 0 times $1.25 gives us our total expenditures of $5. On the other hand, what if we only bought hamburgers? If we bought no tacos and only hamburgers, well, we can only buy 4 hamburgers because 4 hamburgers times $1.25 gives us our $5. Or we could kind of mix and match. Maybe we ate 5 tacos at $2.50 total. 5 times 50 cents is $2.50. And then we ate 2 more hamburgers at $1.25. That's another $2.50. We still spent $5 total. So this is our budget constraint, and this is showing all of the feasible combinations. Remember that budget constraint shows us the feasible combinations that we can consume given a limited budget, and this is our limited budget. So this is showing us our combinations. Now, can we also put this into a graph? And yes, we can, and that's where that budget line comes in. The budget line is very simply just the budget constraint depicted graphically. So the budget line, that budget constraint line, is going to be equal to the negative of the price ratio. Or if we're going to put this into mathematical equation, the slope of the line is equal to negative price of the burgers divided by the price of the tacos. So that particular line will become steeper as the price of burgers rise, and vice versa. If the price of burgers fall, then that line is actually going to become flatter. The line is going to become steeper if the price of tacos rise, or become flatter if the price of tacos fall, just simply because of the way that equation is. We have burgers over tacos. So if the price of the burgers go up, then that line is actually going to become steeper because it's a higher number up here, and it basically kind of offsets that. Versus if the price of tacos actually went up, it makes our denominator higher, making our line flatter. So let's kind of go over the slope of the budget line real quick. How do we calculate that? Well, we said it's equal to negative price of the burgers divided by price of the tacos. So what is the price of our burger here? Price of our burger is $1.25. Price of our taco is 50 cents. 125 divided by 0.5 is equal to negative 2.5. So that should be the slope of our line right here. Let's double check that. How do you calculate the slope of a line? Rise over run, right? So it rose 10 units here, and it ran out, or sorry, let me redo that. As we go out to the number 4, this budget line falls. The taco consumption falls by 10 units as burger consumption rises by 4 units. So if we do that quick math, and we do taco consumption has fell by 10, while burger consumption rose by 4, we come out with this negative 2.5, which is the same amount right here. So what we're doing is, in all of this is kind of some of the mathematical equations, some of the conceptual ideas behind being able to graph this budget line. But all we're really doing is we're saying we have $5 to spend. It costs us 50 cents per taco, $1.25 per hamburger, and given those 3 numbers, how many tacos could we consume for $5? How many hamburgers could we consume for $5? And what are all of the possible combinations in between that would allow us to use up that full $5? So here's an important aspect. All of the feasible consumption combinations are along this line. Here's that point 1, where there is 0 hamburger consumption, and 10 tacos being consumed. Here's that last point where there is 4 hamburgers being consumed and no tacos. Then we had this point right here where we have 5 tacos being consumed and 2 hamburgers. And any point along this budget line is a feasible combination of basically using up our budget. So all feasible combinations, consumption combinations, fall along this budget line. This budget line, the slope of it is equal to the price of is equal to negative of the price ratio. That price ratio is also determined back over here, and it's used in determining this budget constraint table.